This video is on functions. Specifically, it's the second of two videos on linear models, as shown here in the syllabus. A linear model has the general form f of x equals mx plus c, where m and c are constants. Linear models are used to describe situations where one quantity, the dependent variable, increases or decreases at a fixed rate relative to the other quantity, the independent variable. Remember that m is the gradient of the line and y is the y-intercept of the line. In many situations, the connection between the variables is not exact. In the example shown, the graph shows the number of customers at a restaurant every fifth day after it first opens. When we plot a set of data points, we may observe a linear trend, which suggests a linear model may be a good approximation of the situation. In this example, the gradient of the line is 4 and the y-intercept is 6. So the function n equals 4t plus 6 is an approximate model for the data. To find the equation of a linear model, one of three methods can be applied. Method 1, coordinate geometry, will use the formula for the gradient of a straight line and the formula for the equation of a straight line. Method 2, system of equations, will solve a pair of simultaneous equations. And method 3, linear regression, will find the equation of the regression line. In part A of this question, we're asked to find a linear model for W, the amount of water in the tank t minutes after it has started to drain. So if we begin by writing the linear model function using W and t as the variables, then using the information given, writing down two pairs of coordinates. We're told that after 3.5 minutes, there's 930 litres of water left in the tank. So the first pair of coordinates is 3.5, 930. And we're told after 50 minutes, the tank is emptied. So the second pair of coordinates is 50, 0. Using method 1, coordinate geometry, we would next state the gradient formula, which is given on page 5 of your formula booklet. Identifying the points and substituting them into the gradient formula gives a gradient m of -20. This means that the water is draining at 20 litres per minute. Next, using the equation of a straight line, also given on page 5 of your formula booklet, if we substitute in the value of m, and then substitute in one of the points to calculate c. I chose the point 50, 0. So replacing w with 0 and t with 50 gives c equals 1000. So our gradient is -20 and our y-intercept is 1000, and the linear model is w equals -20t plus 1000. To use method 2, a system of equations, once you've written down the two pairs of coordinates, we substitute the values into the function to form two equations. Substituting in 930 for w and 3.5 for t gives 3.5m plus c equals 930. And substituting in 0 for w when t equals 50 gives 50m plus c equals 0. We can either solve the simultaneous equations algebraically or by using simultaneous equation solver on the calculator. From the main menu, if we select equation and then press F1 for simultaneous equations. Pressing F1 again for two unknowns, we can now enter the coefficients for the two lines. So for the first line, it was 3.5, 1 and 930. And for the second line, 50, 1 and 0. Pressing F1 to solve the simultaneous equations gives x equals negative 20, y equals 1000. So m was negative 20 and c is 1000. And as before, the linear model is w equals negative 20t plus 1000. If you're going to use method 3, linear regression, then again, once you've written down two pairs of coordinates, from the main menu, select Statistics. And enter the x coordinates into list 1, so those were the t values. The first one was 3.5, and the second one was 50. And enter the y coordinates into list 2, so those were the w values, so that would be 930 and 0. Then press F2 for a calculation and F3 for a regression. Press F1 for a y on x regression and press F1 again for the form ax plus b. Given a gradient a, or m in our case, of negative 20 and a y-intercept b, which is our c, of 1000. So again, the linear model is w equals negative 20t plus 1000. In part B, we're asked to write down the amount of water in the tank when it starts to drain. Well, it starts to drain at the start, when t is 0, so we need to replace t with 0. Given w equals 1000. Alternatively, we could solve this problem using the calculator by drawing the graph of the function. So from the main menu, if we select Graph, and type the function into y1, so that's negative 20, pressing the x variable for t, and then plus 1000. Pressing Execute to enter the equation. Pressing Shift and F3, View Window, we can then set up a suitable window. So setting Xmin to 0, that's when the tank is full, and setting Xmax equal to 50, that's when the tank is empty, and perhaps setting a scale of 10. Then pressing Execute and F6 to draw the graph. As you can see, the graph is not visible yet as we haven't set the y-axis. And we can do this automatically if we press F2 for zoom and then F5 for auto. To find the amount of water in the tank when it starts to drain, well, this is simply the y-intercept. Pressing F5 for G-solve and then F4 for the y-intercept. We see that the y-intercept is 1,000. So there's 1,000 litres of water in the tank when it starts to drain. In part C, we're asked to find the amount of water in the tank after 30 minutes. So in our model, we need to replace T with 30. Given W equals 400. Alternatively, we can also do this calculation on the calculator. Pressing F5 for G-solve, F6 to get to the next layer of menus, and F1 for a Y calculation. Entering the X value of 30 for 30 minutes, and pressing execute, we see that Y, or W in our case, is equal to 400. So there is 400 litres of water in the tank after 30 minutes.